All right, in the last video, we talked about solving systems of equations by substitution because we could do it by graphing, but sometimes when we try to graph it, it's not exact and it's kind of hard to see where the actual solution is. Remember, the solution is a point. So we need to come up with a way. We need to make sure that we have a way to, I may have already, so we need to make sure that we have a way to do it algebraically. So I came up with this one example right here where I had two different equations, this one system of equation, and then I solved it by substituting one into the other. And then I did another example from Alex. There was another way that we could use to solve a system of equations. And I'm using a different system because sometimes some of the systems make more sense for one method and vice versa. So in this method, if I tried to simplify or substitute, I'd have to either first solve for x or solve for y and then substitute it in there, which can be done, but it's more work. If I look at this, if I combine these two in such a way that I could get rid of one of these equations, then I could then just solve for the other and then plug in. In other words, what if I looked at this? What if I decided to add these two equations together? Let's see what would happen. Well, 5x plus 3x gives me 8x. And then 2y plus negative 2y gives me a 0y. It's gone. And then negative 6 plus 22 is a positive 16. Let me write that a little better. 8x plus 0 is really just 8x. That's equal to 16. When I divide both sides by 8, I'll see that x is equal to 2. So by eliminating the y's, I was able to find x is equal to 2. Right? So remember, our solution, we want our solution to be in the form of a point. X is 2. To find y, just like before, we just need to plug this thing in. So we can use either this one or this one. It doesn't matter. It doesn't matter which one because they're both a part of the system. All right? So let me erase that. I'm going to use the first one just because it's the first one. Doesn't really matter. So 5x plus 2y is equal to negative 6. Well, I know that x is 2. So 5 times 2 plus 2y is equal to negative 6. So 10 plus 2y is equal to negative 6. So when I subtract 10 from both sides, I'll find that 2y is equal to negative 16. I'm going to divide both sides by 2. Y is equal to negative 8. So unless I did some simple calculation error here, I'll know that my x is 2 and my y is negative 8. So when it's down to solving by elimination, you just either need to add or subtract. Now let me mention that in more extreme cases, you can multiply first, but we'll not have to worry about that right now. Let me take a look at another one and just kind of point out what you would do to eliminate. Notice that I have a 5y and a 5y, and both of them are positive. Well, if I added them like I did over here, I would say 5y plus 5y. That's 10y. That doesn't eliminate anything. So instead, I would subtract. And just very quickly, I'll do that very quickly on here without doing the whole process. I will say 4x plus 5y is equal to 5. And then 8x plus 5y is equal to 25. Well, I need to subtract everything here. And notice that I put parentheses around. I know you hear me in class saying that all the time, but I always use parentheses whenever I can. So 4x minus 8x is negative 4x. Cool. 5y minus 5y, oh, it's gone. And then 5 minus 25 is negative 20. Divide both sides by negative 4, divide by negative 4. X is equal to positive 5. I said I wasn't going to do it, but man, it's just such a nice flow right now. I can use either of these. I'm going to use the first one just because it's the first one. I know x is 5, so 4 times 5 plus 5y is equal to 5. 20 plus 5y is equal to 5. Subtract 20 from both sides. I'll see that 5y is equal to negative 15. Divide both sides by 5. Y is equal to negative 3. So by solving this by substitution, I found that x is 5. By elimination, and y is negative 3. And again, unless I rush too quickly, we should be good. All right? Solving by elimination is great when you have it in standard form. Use any method you'd like.